Okay, so today we're going to start with our distance, rate, time problems. The first concept that we're going to discuss is uniform motion. Okay, uniform motion says that we are going to be going at a constant rate. So in these problems, our rate is constant. As we go on in algebra, not in this class, but as you go further in algebra and other classes, you will find that, of course, the rate is not always uniform, but we're only going to work with it in that context. So the important formula that we will work with is that distance is equal to rate times the time, okay? The easiest thing to remember about that is, let's just talk about a typical trip that you might take. And you're on the highway and you're driving with your family and your car is traveling 70 miles per hour, which means that every hour you are driving 70 miles. That is what that means. So your rate, 70 miles per hour, okay, mph, okay, times your time. So let's say you're driving for 3 hours. 3 hours. That means you will have driven 210 miles. Okay? So that's all we are talking about here. So this distance equals rate times time becomes very, very important for these problems. So we are going to start quite simply with same direction travel. Now, what we mean in same direction travel is that if one vehicle leaves the station, okay, and travels in this direction, and then we have the second vehicle leaving the station, they are going in the same direction. Okay, now usually one is going faster than the other. In this case, I'm just not sure who's going to be faster, but one usually leaves later than the other one, and at some point they actually will meet, and that's going to be what we are mostly concerned about. Typically we're going to be looking at what time do they hit the same point. Okay, so let's look at a sample question, and I'm going to just kind of reconfigure my seating here. So we've got a group of campers, and one group leader left in a canoe. Now, sometimes it helps to draw things. If you look at your book, and you can look at it when you get back to school, since you most probably don't have it, they actually make a chart. I usually draw things. So I'm going to be drawing somewhat of a canoe, okay? I have my paddle here, okay, coming out of my canoe. And my canoe is going to travel at a rate of 10 kilometers per hour, okay? And a little bit later, a group leaves, and it's exactly 2 hours later. So we're going to have a motorboat, okay, with a big motor on the back. That's the propeller. This guy's got like a you know, it's like a much faster boat, okay? There's no oars here, okay? And he is going to be traveling in the same direction, and he is going to be going 22 kilometers per hour, okay? And he leaves 2 hours later. He leaves 2 hours later. What you'll find is that at some point you will figure out what works best for you as far as setting things up, okay? So this is how I like to do it. And like I said, the book does a lovely chart. I'm not a chart person. I need to see the visual person. Okay, so my distance, what they are asking is, how long after the canoe left the campsite did the motorboat catch up with it? Okay, so I know that this is going 10, this is going 22. These left 2 hours later, and they want to know when, how long after the canoe leaves did they actually meet, okay? So we know that our distance is going to be equal, because it's going to be when they both hit this spot right here, okay? When they both get to that spot. So my distance is equal. So what I'm looking for then is the rate and time of my one vehicle, which is my canoe. It's got to equal the rate and time of my second vehicle, because in essence I'm saying distance equals distance, and that's what we're saying. We want to meet at that one distance. So let's put in our numbers our rate. That's pretty easy. I've got a 10 and I've got a 22. There's my rate. Now my time. Okay, I don't know exactly when they left. So my time for the canoe is going to be X. Okay, now my time for the motorboat, let's say X was 12 o'clock. Okay, this one, he didn't leave till 2 o'clock. So that's X minus that 2. He doesn't have that 2 extra hours. So here we're at X minus 2. Okay? Now, all I have to do is solve it. This becomes 10x equals 22x minus 44. Okay? And I will subtract 22x from both sides. Subtraction property of equality. This gives me negative 12x equals negative 44. And now I will divide both sides by negative 12. And x will equal, okay, so I know that this is a positive number, okay, because I've got a negative divided by a negative. I know that 12 will go into 44 3 times for 36. That leaves me with 8 over 12. Okay, if I reduce that, what do I get? 2/3 I get, so that is 3 2/3 hours. Now, let's go back to our original question. The question is, how long after the canoe left the campsite did the motorboat catch up with it? Okay, well, does this answer our question? Okay, well, yes, it took 3 2/3 hours because, see, my x is related to the speed of my canoe. Okay, so after 3 2/3 hours, that is how long the canoe traveled. Now there's a part B to this question. You always want to make sure that you look at both. Okay, how long did the motorboat travel? Well, now all we have to do is go back to our time up here. Okay, this is the canoe time here, and the motorboat was whatever the canoe was minus 2 hours. So the motorboat, and you can't really see, but I'm actually writing motorboat. Hold on, there it is, motorboat. 3 2/3 minus 2 is 1 2/3 hours. Now, hopefully I've explained it all enough so that you'll be able to work a couple of problems tomorrow. So until next time.